Hello, I'm Daniel. In this video, I will demonstrate my assignment for a project. So it includes ERC20 token, ERC721 NFT contract, automated tests, front-end app, re-agency security exploit, and industry voting portal. So this is the main structure of my project. So let's say about ERC20. Here it is my token solidity file. So it is built with OpenZeppelin. It supports standard ERC20 functions like transfer, approve, allowness, and transfer from. It also uses ownable, so only the owner can mine new tokens using the mine functions. Here, function mined, and also ERC20 also emits transfer and approval events automatically when transfers or approvals happen. So let's deploy our token like this. You can see the address. And next thing is about my NFT. My NFT. This is my ERC721 NFT contract. It includes minting and token URI logic. So here, so each NFT can store metadata via URI. So let's also deploy it. And we see the address and also about file deploy NFT and mint NFT. Mint NFT, let's mint NFT. So this script mines free NFTs with metadata URIs, so we can later display it in front-end app. Now about testing, NFT test, token test. Let's see the test. I wrote unit tests for both ERC20 and ERC721 using Hardhat. So ERC20 tests cover minting, transfers, approvals, allowance, transfer from, and reward conditions. ERC20 721 tests cover successful mine, token shape checks, and token URI retrieval. So how about front-end app? So here index.html. Here it shows like this, connect MetaMask, and it shows the balance with token and address account. And also my NFTs here is token ID and metadata. And now let's send some amount of tokens to accounts that I got from this when I open the server, and it shows like this. And when I do like this, and it will show this notification in MetaMask. Here is more detailed information, and let's send it again. But at this time I will deny, and it shows like this, that user denied transaction, also as 0. So here I loaded my NFTs, transferring ERC20 tokens, also showing information about account. Now about security re-entrancy test. So as I showed here, re-entrancy vulnerable bank. So I demonstrate the classic re-entrancy vulnerability. The vulnerable contract sends Ethereum before updating the user balance, which allows the attacker to re-enter and withdraw multiple times. So the fixed versions uses re-entrancy cure to prevent re-entrancy. So here you can see that vulnerable bank before was 5 Ethereum, after 0, fixed bank before 5, and after 5 Ethereum. Now about interesting use case. I implemented a simple on-chain voting workflow to deploy voting. So let's deploy voting. Wait, deploy voting. See the address. And now let's open the console. So here the owner means me, can add candidates and open voting, and users can vote once per address. Results are stored on chain. So let's first we are writing like this, and here I am writing this address that I got, and now I can add candidates. like for example, I don't know, like this, and it shows like this uh, hash. So let's add some different person. No, and it shows like this. Now uh, let's write like this. I mean, wait, loading set open to like this, and it shows like this. So next thing is about connecting one. So what one and like this, but let's just now write get candidate, and it shows like this. Like this. So in conclusion, this project demonstrates ERC20 and ERC721 development, automated testing, front-end integration, real security exploit, and fix an industry-leading workflow. So thank you for watching.